Okay, good morning, my outstanding friends. It is Roger once again, and today we're going to be looking at this disaster that's going on with these electric vehicles and the fires that are starting from them. And this is Hurricane Ian submerged all these electric vehicles, and now they're literally exploding in flames. And over again, it doesn't just happen once. Once they start, they may reignite a couple of weeks later. Listen to this now.
A week after Hurricane Ian swept through Florida, there's a dangerous problem involving electric cars. First responders say flooded out electric vehicles are now catching fire, and putting the flames out isn't so simple. News Nation senior national correspondent Brian Inton joins us live. And Brian, not only are these batteries catching fire, they can also reignite.
Yeah, Nicole, that's the big problem is the firefighters will respond, put the battery fires out, and then the fires will reignite, and the firefighters have to keep coming back over and over again. The issue is the batteries on many of these Tesla models are up underneath the car, so you can imagine with the storm surge during the hurricane, many of the cars were totally covered. The salt water corroded the batteries and started causing fires. Hurricane Ian was a once-in-a-century storm causing flooding like never before on the west coast of Florida.
Another problem with EVs.
And the hurricane caused something else never seen before: exploding electric cars. The electric vehicles were submerged during Ian, and the lithium ion batteries flooded with salt water from the storm surge. Now they are catching fire. What's making these electric vehicles basically explode?
So you have the stored energy in the battery. So just because the vehicle is submerged doesn't mean that energy is discharged in any way. Anytime you mix, electrical components and salt water together, it is a recipe for disaster.
The North Collier Fire District had to cut open a Tesla and spray down the battery that was on fire. Just this fire department says they've had it happen 4 times in 1 week.
I think that as we've moved over to electric vehicles, this is the first time we've seen anything like this.
The issue is the batteries in the car can reignite over and over again. Florida State Fire Marshal Jimmy Petronis says it takes a lot of water and foam to put them out for good. With the EV technology being so new, do you think we should be concerned?
I do. So look, it was a natural disaster. And we learned something from every single natural disaster.
That's the key. Learn something. All right, so what can we learn? Well, we know right now those batteries are very low in these cars. And that storm surge brought the water up. And it's salt water. And salt water is highly corrosive and conductive. And it causes all kinds of problems with these batteries, and then they start to ignite. Not only to that, if you think you're okay with your car and you bring it home, put it in your garage, you could lose your house. Listen to this. This is important. This is why I need to tell you, all you people, think about this carefully. These electric cars, it's a great idea, but we need to have some safety precautions implemented, and I think I have some ideas. Listen.
Natural disaster. We truly do. And what we are learning from this one is EVs are not compatible with salt water. When they become inoperable, when they have shorts, when they have corrosion issues, and they're inoperable, and they're actually in your garage, as a lot of cars were because of this storm surge event, they become now a fire hazard for your house.
And the state fire marshal telling people on the west coast of Florida, if their Teslas or electric cars were flooded and are inside their garage right now inoperable, to actually get a tow truck and have those cars pulled out into the driveway or push them out. It's not worth the risk that they might catch fire while they're in your house. We reached out to Tesla today, but did not get a response.
All right, let me go back to even an accident on a car. How I started into this was looking at when they have accidents, they have some serious issues with these batteries blowing up and turning into fires. I mean, really serious fires. Even in just an accident, if you damage these batteries, this is the National Transportation Safety Board. They're saying safety risks to emergency responders that are going out to put out these battery fires. And the battery fires are happening after accidents and so forth. Now, additionally, we're seeing it with these saltwater floods. but these can be very, very volatile. Okay, most everybody understands electricity can be dangerous. And batteries are nothing more than storage of electricity. They come to put these fires out when that electricity short circuits and creates enormous amounts of heat, and then they burst into flames. Well, they come out and put the flames out, but the batteries inside themselves still have this residual electricity, and it can get plugged up and start all over again. Pressure, heat, explosion into fire. They keep reigniting, and I mean they can be bad. And when you have a car that's got a problem with its batteries and it's in your garage, you could lose your house. So what they need to do is put in a failsafe. Now, to understand how to design a failsafe, which means when something fails, you want it to be safe when it fails. Let it fail in a way that doesn't cause fires and destruction. Now, here's the problem. They don't understand what atoms are made of. They say there's one gigantic proton and one gigantic neutron and one tiny little electron, which is 1/1836th of a neutron and basically a proton. They say these are just one big gigantic particle, and that's 1836 times smaller than these particles. No, this is one particle, and these are made of 1836 electrons, and this is made of 1835. That gives it a +1 charge because it wants to attract one more electron, one of these, to become 1836 and become neutral. That's the key. Ponder that for 1 second. All right, here's the issue. They think that a proton and a neutron are just one big gigantic ball of solidness, and an electron is one just little tiny ball of solidness. But that tiny little ball is a -1 charge, and this gigantic ball is a +1 charge. Doesn't make any sense at all. The reality here, I wrote over the top of what they say, and I'll show you what they say in a second. Here's what I say. I say that a proton is 1835 of these electrons, but an electron is not just a negative. An electron is a dipole. It means there's a positive and a negative. So this one, when you add 1835 of these positives and negatives together, you're short one negative. So it becomes a +1 charge, and it wants one more of these to become neutral, which is the neutron. That's all it is. There's just bigger and bigger balls of these little tiny particles. Not one big one of these right here, and not one big one of these right here, and not one of these tiny little ones down here. All right? That's just not reality. The reality is the tiny one, yes, but it's a dipole. It means not just a negative, a positive and a negative. And then you go to 1835 is a proton, which wants one more electron, one more of these to become a neutron, which is neutral. It says 1836, I don't want any more, and I don't want to give any away because I'm neutral. I have no charge. Now here's what they say in physics. Here's what they say. The relative mass is 1. There's just one big particle there. No, it's not. It's 1836 of these particles. And then they even say down here, in reality, they don't even know what reality is. Protons and neutrons don't have exactly the same mass. Neither one has exactly 1. No, one of them has just 1 less than an electron. Let me show you what they think the nuclear model is made of, and I'll show you mine. Okay, I know a lot of people are not interested in the deep details, so you might as well stop right now. Just don't have your car in your garage if it's been damaged with the batteries. Now, how can we create a failsafe? And what would the failsafe do? Well, there's 2 things that happen that I know of for sure. is that pressure builds, and I believe that blows the seals out, and then you have dead shorts, and then you get your fires. Now, what would you use for a failsafe? Well, obviously you need some kind of a pressure sensor. If there's a lot of pressure, you want to have some kind of release valve. Then in addition to that, if there's some kind of short circuits going on, you want to be able to actually direct that to ground if you possibly can. But tires, you can't short the ground through the tires. It would have to drop some kind of a conductive foil, you know, like a wound up conductive carbon, something very conductive in a wound up thing, and it would discharge and just spin down and touch the ground and short all that stuff to ground rather than start the fire. Something like that. Because right now, this is dangerous. It's very dangerous as far as I'm concerned. Okay, we're going to get deep into isotopes, because isotopes is nothing more than extra electrons or missing electrons. And that's the electron. An electron is both an electron and a muon neutrino touched together. I've shown it hundreds and hundreds and hundreds of times. Photons are nothing more than two electrons together. They will bounce, but these will try to burn into you because they only have one field. These have two complete fields surround them, so they bounce off of you. And depends on how hard they hit and what they are hitting as to what color you'll see, because the color is the speed of the spin. Again, I'm going to get really, really deep into this. Nobody understands this now because they don't understand an electron is a dipole, and the electron has the dark matter, and the electron has the weight of that dark matter, and the weight of the electron is almost nothing. The way I calculated it out, the weight of the electron part is only 0.0435% of the universe. I'm saying that the universe is divided into two things: the electron neutrinos and the muon neutrinos, and normally they're glued together. If that's true, and I can't tell you it's true or not, but I can tell you pretty much for a fact, these two do glue together and they can break apart. And that one has almost no mass to it. It's just a burner. It burns down houses on a nuclear bomb, and then a second later the black one comes and just knocks it away. And I've demonstrated this so easily. It's just very easy to see. It's no question what I'm showing is correct. And they even say the same thing as Fermilab. It's just that they want to be able to do it with head-on collisions, spend a ton of money. I want to do it cheap and be able to focus them instead of just having a big blob of stuff explode. And we have done all of this. So again, I'm going to get deep. Just go, don't stay with me if you don't want to on this deep stuff. But this is where you need to be if you want to understand physics, science, matter, geology, literally anything. Because if you don't understand what matter is made out of, you're lost. Okay, here's the standard model, and it does not work. It typically consists of three particles: the proton, the neutron, the electron. Well, I say the proton and the neutron consist of electrons, and the electron itself is not just a minus, it's a dipole, which means it's a plus and a minus. And this is all pluses and minuses added together. So this really looks like this. And those look like one of each one of these little particles. But each one of these little particles is a magnet. It's got a plus and a minus side. All right, this is my model. All right, and this works. I can't find anything it doesn't work for. And if you think you have something that I can't explain, I want to hear about it, because I will explain it using dipole electron flood model. As I said before, the electron consists of two parts. One is the muon neutrino, and the other is the electron neutrino. Together they would form what we always considered was an electron, but it is a dipole. Now, two of these back to back like little bar magnets, because they glue. The black is gravity. It wants that white, or the white wants the black. I don't care how you work it out. But the black dark matter can collect on itself. It doesn't try to push itself apart. It wants to be together with everybody. The black ones can be together and the white ones will surround it. This is what an atom looks like. All right, so we have the electrons, which consist of the the neutrinos. Then we have the photons, which consist of the what they call gluons, which I say are electrons. Then we go from the photons up to this 1835 and 1836 number of these particles make the smallest atom, which is hydrogen 1. Now, what would it look like if you could see that atom? You would see a black core surrounded by the white particles, because the white particles do not want to touch each other. They want to go as far apart, and the black ones don't care. So it appears to me that all atoms will have a dark center surrounded by a bunch of white particles that want to get away from each other and push that black into the center. And they form at certain quantities. They call them periods, periodicity. And I can go along with these quantities, but they're not 1 and 5 and 6 and 25 and 92, and they're hundreds and thousands and hundreds of thousands. Because for every particle that they talk about, it is 1835 or 1836 actual particles. And then, in addition to that, each one of those particles is 2 pieces. So it just keeps going. Now, excuse me. Now, what do we have here? We have molecules. All right, first of all, you have atoms. An atom, independent of everything else, this is a hydrogen. It has 1 electron. You see that it's still a red and a black. And the red wants to get in, which is the attractive part, wants to get to that black, but there's so many white ones already surrounded. It says, no, you stay away, you can't get in. And it says, well, what do you want me to do? And it says, well, stay 5 angstrom units out, that's far. And just stay out there and you're okay. We'll push you, you try to come in and we're okay, we'll be stable. All of a sudden you had a whole bunch of more electrons. Heat, scrubbing, friction, all of that. Now you end up with heat and everything's vibrating around, and all of a sudden it'll explode and go into flames because all of these little particles will go flying off on their own. That's what electron showers are, or literally are extreme energy, and they can form flames. Molecules are nothing more than atoms attached to other atoms. And their electrons in the cloud here share the electrons of the other ones. Now when we collide these like we did, we get the showers and we get the muons all by themselves, sterile muons. So this model, it just absolutely does not work whatsoever. And look at this. I can't understand how they can possibly miss this. You've got an electron, which is very, very, very tiny. It weighs 0.000548858 atomic mass units, okay? Look at this. These two are only separated by 1 electron, a proton and a neutron. This one here is 1835, which is the proton. You add 1 more electron, it makes it 1836, and it weighs that. All right? You see the 3 and the 5? It adds the 3 and the 8? Dude, the difference is 5. I can't imagine how they missed this. It couldn't be any more obvious than this. They say a proton weighs this much, 1.0073. Then you add a little bit more and you get to a neutron, which is 1.0078. Now, watch this. If you take the neutron, which is the 1.0078, and subtract the weight of the electron, which is this very tiny 0.0005, you end up with 1.0073, which is the proton. So the only thing you're doing is adding 1 more electron to a proton, and you end up with this number, 1.0078. If you take the electron back out, you end up back at the proton. And that happens, and it does go both ways. Those are called isotopes. Sometimes you add extra electrons, and sometimes you take some away. and then they become radioactive, basically. They become unstable. A stable molecule will have just the right number of electrons to say, I don't want any more electrons, and I don't want to give any up. I'm a stable particle. I'm completely stable. If you have extra electrons or not enough electrons, it'll say, I'm going to look around and see if I can find a guy to steal an electron from or give some of mine away because I just don't feel good. I'm not stable. I'm not stable. Okay, this is the Department of Energy, and they're explaining isotopes using the standard model, and I disagree completely with their portrayal of hydrogen 1, 2, and 3. I am going to draw in my own hydrogens here and explain it. All right, this is, as you saw, the Department of Energy. This is one big black, center positive core and one tiny little negative. It's not that way. These are all dipoles. Now, the black will push its way towards the center, primarily, and the whites will surround it. Now, there might be some whites around in the center here. I can't say one way or the other, and I do believe there might be because I've seen experiments that show that structure occurring, and I'll show you those in a minute. But trying to get into this dark center, which is so attractive, is what another electron wants to get in, because the size of it is just big enough to attract only one more. If it was bigger, it would attract two. If it was bigger than that, 3, 4, 5, hundreds. Depends on the size of the core. So it will always be surrounded by this type of mass, which is the pushy shovey, and there was always going to be another one that wants to get into that. And bigger it gets, the more want to get in, the more will surround it. Now, the only difference between hydrogen 2 and 3 is they say, well, let's throw in a neutron to make up for the weights of these things, because there can only be one electron. No, there's 2 electrons in this cloud. And that is not a neutron, that's another 1835. So you have 2 1835s and 2 electrons out here. 3, you have 3 1835s and 3 electrons. These are not neutrons with one extra electron than the protons. They're the same as like that proton having that attractive force, and then the extra electrons that they're saying are part of the neutron are not. They're out here. Okay, one last look. Department of Energy says that's a big proton. I say no, it's 1835 electrons. One more wants to get in, and it pushes it away. It could be 1836. It's right in that area. But it's a ball of these same particles, and there's one more wants to get in. It says, no, you can't because I have a crust around me. We're going to go view that in a second. And the same thing here and the same thing here. They're just bigger and bigger balls of the same particles. See this? These are isotopes of hydrogen. They don't just have those 3. They go all over the place. You see them? And they keep adding extra electrons into the mass or taking some away. The basic one is 1.0078 mass. But then you go to number 2, number 3, 4, 5, 6, 7, all kinds of different particle sizes added in here. But the only 2 that are stable is the hydrogen 1 and hydrogen 2. They're fairly stable. Now, the rest of them aren't, and then they go by half years, how long it'll last, a half-life, how long it'll last, days, minutes, seconds, and so forth. And what does it break down to? What's the daughter isotope? You got helium coming out of here. See, they don't know what that is. Question mark, question mark, question. There's a lot of stuff they have no idea about. But I can tell you what, this is not what a deuterium atom looks like. Deuterium is just one bigger ball of the same particles, and then 2 particles out here, 2 electrons, not just 1. Now let's go see some experiments. Okay, everybody's favorite, Nikola Tesla, another one destroyed by academia. If you want to find the secrets of the universe, think in terms of energy. But energy is created by frequency and vibration. They quoted him wrong. They say, think in terms of energy, frequency, and vibration. Well, it's energy is created by frequency and vibration. Let's look. All right, you see what you got here? This is frequency. That's positive, negative, positive, negative, positive, negative. And that's what they're going to do, and shake this plate up and down, which is nothing more than shaking electrons in and pulling them back out. That's exactly what frequency is, up and down of the input and pulling out of electrons. Now watch what happens when they go on. He's turning it up. Now this is a solid plate of steel, and they have these, like they're sending electricity in and bringing it back, in and out, in and out. That's all they're doing. So what they're doing is pushing electrons in, pulling them back out. And they're doing it at a certain frequency. Frequency means how many cycles per second are they pushing into this thing. Now we have 345 hertz. That's cycles per second. So 345 times it's shaking up and down. These are salt particles. Salt is NaCl. They're both sides of the periodic chart. Na and Cl. So they have a polarity, basically. Now watch what happens when they turn this thing on and they start sending these shaking waves through this plate. Watch what happens. At 345 hertz, boom, what do you get? This, to me, is the central core, which is your black matter, surrounded by that white that I showed you before. And then you have up to around these four regions that surround that central core. And this is hydrogen. And you could have an electron here, electron here, electron here, or an electron here. Depends on how much you stuff into this core. All right? And that would be this surrounded by this white particle. Now, they're going to go up in frequency, and it's going to get more complicated. So now we're going up. They're just going back to shake it. Here we go. Now we're going to see what they call is the rule of 8. You're going to see 8 orbitals come out there. All right, so here we go. It's shaking it up. Zip. All right, so what do we got? Right down around the core. This time it's a little bit different. We've got some white stuffed in the center. We've got black all the way around it, but we have that core around there trying to keep out the additional particles that want to get in. So this is basically like it looks to me just basically what you'd expect to see inside of the first stable, like one of these particle of 8 surround them. And then it gets more and more complicated. This is a little tricky, but it gets more and more complicated, 3240s. But see, look at this rule of 8. The rule of 8 keeps showing up over and over and over. I'm sure you could figure this out. There's 8 around here somewhere. 1, 2, 3, 4, 5, 6. You see, it just keeps showing up over and over. And then you get to some certain places where I really can't explain it, and I think that might be like copper and some of the metals that have so many extra electrons that they form strange patterns. But look at the patterns. Isn't this incredible? And they just keep going up in the hertz, and they just keep getting more and more complicated. And I believe this is basically what's going on inside of atomic structure. Because atomic structure in my world is nothing more than these little tiny particles glued together. Positives and negatives, the muons and electron neutrinos. They're glued together. And then when you bring them into a mass, they all have to have their own regions. They push and shove, and then they all sort of stabilize. You stay there, I'll stay here. You stay here, I'll stay there. And then, boop, they lock in. But every one of these little tiny particles is an electron, which is a positive and a negative. And it's pushing its neighbor, and it's all being very, very complex. Very, very complex. This is nothing that just happened accidentally. But it all stems from light, and light being what I call atomic vapor, which means all they are is positive and negative little particles glued together as a vapor. That's what electrons are. And that's what issues from the sun and from every source of radiance. Okay, again, fair use. This is Latham's Crazy Machines, Incredible Tractor Beam Magnets. Now, he's showing something that physicists don't understand. This is the nature of the nucleus. What he did was he took all the negative particles and put them, by turning the magnets up one way or the other, you have positive or negative. So he's got the negative surrounding the core, and he's going to put a big positive in the core. And that will simulate my particles I talk about being the core is the dark matter surrounded by the pushy particles. Okay, so he's going to, and this is a brass ring, so it doesn't have any magnetism. These will each have a field surrounding them, big fields surrounding them. All right, so they won't let any more white ones come in to try to attack that black particle. Now I'm going to play this and explain it as we go along. Don't forget now, this is Latham's Crazy Machines. All right, so here he goes. He's got the brass ring. He's got 6 magnets in their negative. Now watch, see that positive be sucked up against it? He's pushing it into the center. So now he has a nucleus. That is a dipole nucleus. A dipole nucleus. This is all positive. And these are all negative surrounding. Exactly what I talk about. Now, what will happen if he introduces another electron, which is one of these, that wants to get to that dark matter? And it will. It'll try to. Watch what happens. The dark matter is extremely attractive. So here it comes. He takes this. This is an electron. Bam. What just happened? That electron is trying to get to that dark matter, all right, which is the muon. Electron neutrino, muon neutrino. Well, actually, that's a mistake. Back it up. No. They all have electron neutrinos and muon neutrinos together. But the electron neutrinos end up surrounding the muon neutrinos. Remember that. That's critical. The electron neutrinos surround the muon neutrinos. This one is just a red and a black. There's no surrounding anything because it's just a single electron that wants to get into that black particle. So the red one bumps up against these red ones and it says, no, stay away. And that's where we are now. All right, do you understand? I made a mistake before. Every particle is the same particle. It has a muon and electron neutrino is part of each particle. That's got an electron neutrino and a muon neutrino. And in the center, you have electron neutrinos and muon neutrinos all over the place. But you also have a coating always of the electron neutrinos. They'll always be around all because they want to be away from each other. All right, they'll be glued up to the black, but the black will always be in the center. I hope that helps you see it. Now, let's watch what happens here as he starts shaking it around, because it'll stay attached. It doesn't want to leave. It's going to stay exactly right there between those two fields. You see the two? You see the two fields here? That's surrounding. There's a field here and a field here, and it's caught in between the two fields. It's trying to pull it in, but it won't allow it. So now he's going to start shaking it around. What is shaking? Shaking means there's some heat. And what is heat? Heat is some excess electricity, electrons being pushed through there, some photo, interaction, some pushing and shoving. And he's bouncing it around and says, I'm not leaving. And he says, oh, yes, you are. And boom, there it goes. That's called light. It's called electricity. It's called static discharge. Watch this. Boom. That's it right there. The last part was when that extra electron left. That's light, electricity, static, lightning. It's a pushing and shoving of electrons so hard that it leaves its place that it was normally attached to. Okay, I'm going to leave it at this. On my other channel, I'm going to go real deep into all the weights and the measures and how, the whole shooting match, how we can tell how much these different things weigh, and very, very deep. But for right now, I want to tell you, we should be able to harvest free energy using this particular technique, squirting these particles onto a substrate, which could collect them. And this stuff is readily available. It's already on the shelf, basically. There's a little construction work to do, a little engineering, but it shouldn't take more than a month or two to actually have these things in operation. If this does what they say it will do with fission and fusion, which is exactly what we did. We took the same particles that CERN and Fermilab and all see. We divided them here, that's fission. They came back together, that's fusion. These are the muon electron neutrinos, that's what they are. And they create the muon and the electron showers. Shown this hundreds of times. And here there's the particles that I've been showing right along. And here's how they separate. And that is a total gigantic increase in energy from back here. It appears to me, and I can't see why we can't harvest that. All right, I love you. Just think about this. If this works, this is the kind of device you would need, something about this size, to power a house, a car, and you could carry it around, and you have any kind of plug you want to use, AC, DC, anything. You just select what kind of voltage, what kind of, whatever it was. Just think what that would happen in Ukraine if they had this. Just think of what would happen in Florida if they had this to go back to their houses with and so forth. No power grid required. I may be a dreamer, but I'm not the only one.